Hello, classmates. As we all know, matter in nature exists in three states: solid, liquid, and gas. Today, the electric arc we are going to learn about is the fourth state of matter, plasma, and specifically, a high-temperature plasma state. So how is it formed? Today, we will learn about the ignition and extinction of electric arcs and the process of arc formation. In this lesson, we need to master the concept and characteristics of electric arcs and the physical process of arc formation. Moreover, through this study, we will cultivate a meticulous and conscientious work attitude, enhance electrical safety awareness, and develop a sense of social responsibility. The key points of this section are the characteristics, hazards, and physical formation process of electric arcs. The difficult point is the physical process of arc formation. Now, let's watch a video showing an arc flash accident that caused casualties and equipment explosion while 3 workers were inspecting a 35 kV distribution cabinet in a factory. This video illustrates the significant harm electric arcs can cause to electrical workers and equipment. Now, let's understand what an electric arc actually is and what its characteristics are. An electric arc is a common physical phenomenon in power systems and electrical energy applications. When a switching device breaks a circuit, and the voltage and current reach certain values, immediately after the contacts separate, intense white light is produced between the contacts, which is called an electric arc. The essence of an electric arc is a gas discharge phenomenon. Its characteristics include very high temperatures, self-sustaining discharge, and being a stream of ionized gas. After understanding the concept and characteristics of electric arcs, we need to know what hazards they pose. When breaking or making a current, it is inevitable that an electric arc will form between separating contacts. This poses significant hazards to power systems and electrical equipment in switchgear. There are 3 main hazards. First, high temperature. The high temperature of the arc can burn out electrical contacts and surrounding components. For oil-filled equipment, it may also cause fires or even explosions, endangering the safe operation of the power system and resulting in casualties and major property losses. Second, the circuit cannot be disconnected. In switching devices, even though the contacts have separated, as long as an arc exists between them, current continues to flow. The circuit is not truly broken until the arc is completely extinguished. The presence of an arc prolongs the time it takes for switching devices to break fault currents, exacerbating the harm caused by short-circuit faults in the power system. Third, the inherent hazards of arcs. Since arcs can move under electromagnetic and thermal forces, they can easily cause flashovers, short circuits, injuries, or escalate accidents. Therefore, it is essential to develop a meticulous and conscientious work attitude, enhance social responsibility, and improve self-control and management skills. Nowadays, with the development of science, technology, and industry, we have widely applied dangerous electric arcs in manufacturing. Now, please watch the video.
With the advancement of science, technology, and industry, the application of electric arcs has become increasingly widespread. Arc plasma devices are widely used in cutting, welding, spraying, machining of refractory materials, chemical synthesis, heat treatment, and space propulsion. The plasma torch is specialized equipment developed based on this principle. The plasma torch uses an electric arc to produce high-temperature gas, which can operate in oxidizing, reducing, or inert environments. It can provide a heat source for various industrial furnaces with functions such as gasification, pyrolysis, melting, and smelting. Second, arc welding. The characteristics of the electric arc play an important role in the quality of the welding process. A welding method where the metal to be welded serves as one electrode and the welding rod as the other, and an arc is generated when the 2 electrodes approach, melting the metal and the welding rod, is called arc welding, commonly known as electric welding. Third, arc furnace. Some steel is produced using arc furnaces. Vacuum arc furnaces are used to produce small quantities of pure metals. An electric furnace that uses the high temperature generated by an electrode arc to smelt ores and metals. When a gas discharge forms an arc, the energy is highly concentrated, and the arc zone temperature exceeds 3000 degrees Celsius. For melting metals, arc furnaces offer greater process flexibility compared to other steelmaking furnaces. They can effectively remove impurities such as sulfur and phosphorus, allow easy control of furnace temperature, have a small equipment footprint, and are suitable for melting high-quality alloy steels. Fourth, the light effect of arcs. Electric arcs can be used as light sources. The carbon arc lamp was the first practical electric light source used by humans before Edison invented the incandescent lamp. Today, arc lamps are still widely used. Since arc lamps utilize the light emitted by arcs generated between electrodes, they have high color temperatures and strong brightness. The color temperature is very close to that of daylight. They are now commonly used as lighting for outdoor color photography.
After gaining a preliminary understanding of electric arcs, how are they actually formed? First, strong field emission. At the moment when a switching device opens, since the distance between the moving and stationary contacts is very small, the electric field strength between the contacts is extremely high. This strong field pulls electrons out from within the contacts, forming strong field emission. Second, thermionic emission. When the moving and stationary contacts of a circuit breaker separate, contact pressure and contact area gradually decrease while the contact resistance increases. This causes intense heating at the contact point, leading to a sharp rise in the cathode surface temperature and the emission of electrons, forming thermionic emission. Third, collision ionization. Electrons emitted from the cathode surface move at high speed toward the anode under the influence of the electric field. They continuously collide with neutral particles. When a high-speed electron has sufficient kinetic energy, it can knock one or more electrons out of a neutral particle, ionizing the neutral particle. This process is called collision ionization. Fourth, thermal ionization. Gas molecules in the arc column undergo thermal motion under high temperatures. When neutral particles with very high kinetic energy collide with each other, they become ionized, forming electrons and positive ions. This phenomenon is called thermal ionization. The conductivity of the arc column is maintained by thermal ionization. Therefore, it is essential to enhance electrical safety, awareness, and professional competence. Now let us watch a video on the formation of electric arcs.
During the opening operation of a switch, the movement of the moving contact causes the contact area between the moving and stationary contacts to continuously decrease. This leads to a continuous increase in current density. The contact resistance increases as the contact area decreases, causing the contact temperature to rise and resulting in thermionic emission. When the contacts first separate, the gap between them is extremely small, resulting in a very high electric field strength. Under the influence of this electric field, electrons continuously escape from the metal surface, becoming free electrons moving between the contacts. This phenomenon is called field emission. Free electrons generated by thermionic emission and field emission accelerate toward the anode under the electric field force. Along the way, they continuously collide with neutral particles, knocking additional electrons out of them. This phenomenon is called collision ionization. Due to the chain reaction of collision ionization, free electrons multiply, and positive ions increase accordingly. Large numbers of electrons rush toward the anode, while large numbers of positive ions move toward the cathode. The gap between the switch contacts becomes a channel for current flow. The dielectric between the contacts breaks down, forming an electric arc.
Through this video, we must enhance our electrical safety, awareness, and sense of social responsibility to prevent unnecessary harm. This lesson mainly covered the concept and characteristics of electric arcs and the process of arc formation. We focused on the process of arc formation and the hazards of electric arcs. Now, classmates, please consider the following questions. 1. Process of electric arc formation. 2. Strong field ionization process in electric arc. That is all for this lesson. Thank you for listening.